Simulations play a vital role in learning. However, it is challenging to make simulations for science subjects. It requires a lot of resources and time to develop scientific simulations. This video is for science teachers or for students who are looking for simulations for science subjects. Not only mathematics, but physics simulations, biology simulations, chemistry, and simulations for some other science subjects. I'm going to show you a few websites from which you can get scientific simulations that you can use in teaching, or if you are a student, you can use for self-study. Most of these simulations are open source and free to use for teaching, with some attributions as explained by those websites. In this video, we are going to discuss three main topics. What are simulations and their purpose? Where to find simulations for your science subjects? And most importantly, how to use simulations in teaching. So it would be more beneficial for you if you watch this video till the end. So without further ado, let's get started after a short intro. So first, let's talk about what are simulations. Simulations are artificial environments created by using animated objects. Students can interact with this environment on their devices to learn scientific concepts. They can act like scientists and researchers. They can see what is impossible to see, like atoms and molecules, and they can use sliders to change the input and see the changing output. In this way, students get the bigger picture and it improves their critical thinking and evaluation skills. So the first website is PhET Interactive Simulations. The web address is phet.colorado.edu. You can type, and there is a simulation tab. They have simulations on science subjects: physics, chemistry, mathematics, earth science, and biology. If I hover over this simulations tab, I can click on all simulations, or I can click on any particular subject. So I click on physics simulations, and now I have 54 results for physics. On the left hand side, I can uncheck the topic that I don't want, and I can get the simulations only on a particular topic, or I can select the complete physics subject. And as you can see that they have put a lot of effort developing these simulations, and these are open source, meaning that you can get even the code of these simulations. You can download them or you can use them online, that I'm going to show you in a minute. But whenever you use their simulations, it is important that you read the licensing terms. And if I click on licensing, here they clearly explain that the following attribution is required when sharing or redistributing a PhET simulation. So you have to add this sentence and this link in your teaching material for the attribution. Now let's go back to the simulations and let's have a look at one of these simulations. So let us select this projectile motion. Now this is the simulation page, and you can embed this on your own website, or if you are teaching online, you can explain this online, which I am going to show you next, and your students can also do the simulation without even signing up as I am doing right now. So I click on the simulation. Now the simulation will appear full screen, and there are 4 different sections. The first is just the introduction. So if I click on that, it will show me some basic features. I can have a look, and because this is about projectile, so a mass will be thrown. I can change the angle. As you can see, by default the mass is 5 kilogram. This is the initial speed that you can change, and this red button is to do the simulation. So if I press this, a projectile will be thrown and I will see the projectile motion. But in the next section, the vector section, we have some more control. We can change the diameter, we can change the mass, we can change the initial speed, and students can interact. So let's start from 60 degree, run it. Now students can change the angle to 45, run it again. And they can understand that if the angle is 45, it goes a greater distance than if the angle was 60 degree. And if they go further down, for example 30 degree, still the distance covered is less than 45 degrees. So they can understand that 45 degree angle of projectile gives the maximum distance. In the next section, drag section, they can even change the drag coefficient. So at 45 degree, if they change the drag coefficient to a little bit higher and they run the simulation, they can see what is the effect. So in this way, they are acting like scientists. They have few parameters to tweak. They can experiment. It will increase their critical thinking as a result. So how cool is this? Now let's go back. So if I click on chemistry now, I have 30 results for chemistry simulations. For mathematics, we have 47 mathematics simulations on this website. So in total, there are more than 100 simulations on this website. Now the second website is CK12 simulations. So if you type this in Google, CK12 simulations, you have physics simulations by CK12 Foundation and you have chemistry simulations. So let us click on physics simulations. Basically, this page also has a chemistry simulations section on it. On the left hand side, you have these filters. So you can choose any particular topic, or you can choose a subject. And we have a lot of physics and chemistry simulations on this website. As I am scrolling down, still as you can see that there are hundreds of simulations. There is an instruction video. You can click on that. That will describe how to use these simulations. For these simulations to use, you must sign up with CK12 organization. You can sign up using your Google account, and on their website, they also mention how to give the attributions, or you can talk to them for the latest information. I have made a video about CK12 a couple of years ago, but the situation might have changed. So you can send them an email and ask how you should give the attribution, etc. The next website is GeoGebra, and I have made a few videos about GeoGebra already about mathematics simulations. But today I'm going to show you that there are some physics simulations on GeoGebra as well. And this is the web address. You can type this and you will reach this page. So let's have a look at this rolling motion simulation. So we have few objects that are rolling on an inclined plane, and on the right hand side you can choose what objects you want. Currently 2 objects are selected. You can't see the other one because it is behind this. And if I run this simulation, it will run it, and there are some numbers here for kinetic energy, translational and rotational. So in order to reset, click on reset, and let's say I select another object, rather all the objects, and click run, and then I click pause. So I can stop it at any time. Again, a very good source for science simulations, GeoGebra. And GeoGebra community is also very active. And I'm sure that there are hundreds of simulations on mathematics, but you may find some other simulations on science subjects as well. Again, you must understand the licensing terms from GeoGebra as well. So the last thing is how to use simulations. So there are 6 important points for this. The first, as I explained, is that you must understand license and attributions. The second point is that you must set clear learning outcomes. And when we say learning outcomes, there are 2 things. What knowledge students will get from this simulation and what skills they will learn from this simulation. So you must clearly state this in a document and share this with your students. The next step is that make a lesson plan, meaning that this simulation must be part of your lesson plan and not just randomly a gaming thing for students. The next point is that you introduce simulations to your students. You explain to them all the inputs, all the parameters as I explained to you in this video, or probably better than that. And then you let them play for some time. Give them some time to play with the simulation so that they get familiar with how it works. And then the final step is that you ask questions from various angles to see whether you have achieved the learning outcomes or not. It could be a formative assessment or journal discussion. And now after this, you should watch this video about scientific diagrams. That is it for today. I hope you liked this video. If so, please give it a thumbs up. Thanks for watching and see you next time.